I'm French Blender user. I'm an architect and I've been using Blender for I think 11 or 10 years, something like that. I teach it in the School of Architecture in France for 7 years now. And I teach it in firms for architects and other people like that. And aside, I created a makerspace in my small town, in which we use 3D printing and the CNC milling machine. And this is what I will talk about today when the screen works. So I will, I have only half an hour, so I will not cover everything about 3D printing. I will not speak so much about how is working a 3D printer. I think now it's okay. I have the same thing than you. I will not cover the modeling in Blender because you can't do anything in Blender. I will try to focus on some examples of how I used Blender in a way that Blender helps me really working with 3D printing and CNC milling. Let me just find, I think it should be this one. So, just, okay. I think everybody's here now. So on my website you will find things more about my architectural and teaching work and what I do with Blender. And the Fab Lab site, the Makerspace site, is Chantier Libre, but it's only in French, so you will have the address at the end. So let's start. Okay, so this is what I said. I will focus on where Blender helped me, and not on how is the 3D printing, and okay, but you will see some things. So this is the plan. I will show some examples of the workflow for 3D printing, how I use it for workshop for children, people that don't know Blender at all and never use even sometimes a computer, but they manage to use Blender to make some printings, and how I use it for CNC machining. So this is the printer we use. It's a Ultimaker. It's an open hardware printer. It's okay. I will not. There are so many printers. It's using FDM, so it's a filament depositing. We will see a video to understand how it's working. So the first example to show a workshop is an idea that I use for some years now in teaching, is to use the work of Gaudi about when you take a rope like that, it takes the shape, the ideal shape for load discharging, and he used it to build the Sagrada Familia and some other things. And you can do it with soft bodies in Blender. And what is interesting is that, let's go this way, I will load Blender. As FDM 3D printing is printing one stack on the top of the other one, layers by layers. So if you use this type of shapes, you should get a shape that is easier to print, because you have a slope that is almost perfect. I don't know where my Blender is. Okay. Now I have two of them. Oh no. French. So this is the example. It's flat. Okay, and you just apply soft body on it. The red parts are elastic and the other ones are rigid. And when you launch the soft body simulation, it's just adjusting and taking the shape, and if you wait until it's stabilized, you should have a perfect shape for the load to go down in the structure. And then you can print it. So the next step is you can use the Blender tools to analyze the mesh. So I won't spend a lot of time on this one. This one is with all the modifier applied, so it's just it's a mesh. And here you have now the mesh analysis that, for example, for overhang, you can check if there is what are the parts that are too flat to be printed. And you see that with this type of structure, I have very limited parts in the middle that could not be printed without support. And then you will launch the 3D, the printer software. So in some cases, you have to use two softwares, one for slicing the mesh and one for sending it to the printer. Here the software that is open source too, given with the 3D printer, does both of them. It slices and it sends it to the printer. So you load in Blender, you export the model in .stl, and then in the software, sorry, the screen is very small, so I don't see the tools. Here you can scale it, rotate it, make some modifications. You have all the settings of the printer. So basically you have the layer height, which will define the resolutions vertically. You have the speed, which, okay, the fastest, the less quality you have, and the temperature and some other things. And then it will start to slice it here. So it will calculate every layer before sending it. So it's working, so I will let it work and just show a video of how it is printing. So this is the same model printing. So I don't have a webcam. I will make the model go through. If you want to look at it, there are two of them. One of them I just use the modifier, I don't find his name anymore, to reduce the number of polygons to make a low poly one. This make modifier. So here I was afraid to print it without the support that allowed the horizontal part to have some support, but I think I could have printed it without support. So we can see that in some time you will need some work to polish and finish the work. So this printing took, I think, something like 15 hours to print. So it can be very, very long. So the problem is not the cost of the material, the problem is the time it will take to print. It should not be white like that. So here is I came back to the software of the 3D printer, and here you can see all the layers one by one. And then when you click on the print button here, you can send it to the printer and it will print it layer by layer. So the workflow is quite straightforward. You just have to model in a manifold meshes, so closed shapes. If your modeling is good, there is no reason it could not be printed. Okay, it was just to show that it's not only for art. You can print mechanical parts. For mechanical parts, generally I use FreeCAD. That is more easy to use for precise things and Boolean operations and things like that. But here, as it was a curvy part, I use Blender for this one. It's to repair a part of a mobile home. So you see the broken part and the printed one. And here, it's the part on the left here. So now I will talk about how I use it in workshop with people that don't know 3D basically. So I sort of cheat to allow them to use 3D software. So sometimes I use Wings 3D when I have time. For example, a half a day, I will use Wings 3D to make the modelization. But when I have less time, this is one of the examples of the things I use. Where's Blender? So it's very basic modeling with curves. So why I use this is because it's very easy to have nice objects, nice looking objects in a very short time. So basically you have two curves. You have one curve that is defining the profile. So it's a Bezier circle, and they adjust, I make them add some points with subdivide, and then they can define the shape of the thing to make stars. It's easy to make stars and things like that. And then they have a second curve. Generally, this second curve is already here, so that they don't have to spend time aligning, putting the curve in the correct axis and things like that. And then they just, generally with 3 curves points is enough. They can move 1 point. They can tilt it the way they want, and they can scale it. So with very few even not shortcuts, I use the buttons here. With very few buttons, they can in 1 hour have fun, make something they like that is personal, and print it and go away with it. So this gives this type of result. So at the left, it was one printing during the workshop with low quality, so that we have time and they take it away. On the right one is another one, but I printed it at home with a high quality setting, so that it looks more beautiful. Next one, I check the time. This one was quite challenging for me. It was during the Folle Journée de l'Architecture, so the architectural crazy day in a school of architecture, and they organized 30 labs in the school, and there was lab with Kapla, lab with drawing, lab with everything, and there was one lab with 3D printing, and we had 4 3D printers, and they asked us to make very short things, if possible 30 minutes workshop, and that the children can go away with the printing. So for that I cheated once again, but I wanted to use Blender. So I was wondering how to make this, and I use Blender, of course. And I will show you the file. I use shape keys to make typical. Let's look at it. It will be easier to understand. Open recent. Okay. So when the children open Blender, he got this. So a simple 3D view. So it was easy for them to move around. I didn't show them how to pan so that they never get out of focus. Blender UE is good if you don't tell them what they cannot do. So you hide everything and it's working. And then I just made this simple house and use the shape keys to define variations. So for example, here is flat roof, and you see it's written in I think part of it is missing on the screen. You have the name of the here is written flat roof, here is written one slope roof, here is written window inside, here is the west face, the south one that is on the other side. And as its shape keys, and a random face, has its shape keys, you can mix them. And so every children had some time to rotate, look around, and make his own mix of the different shape keys, so that without any knowledge of Blender and 3D, they had just a glitch of, okay, what you can do with 3D. And at the end, they had their own house. And it was very funny to see them when it was printing, all of them, and they were calling their parents and said, okay, this is mine, because they really recognized their own house. So in, okay, it's just a joke. So we printed 53 different models in a day. So we had to print it with low quality settings so that it doesn't exceed 15 minutes per model. I have some. Okay, hopefully it will. Fine. I make it go. Okay. So here you have small ones with high quality settings if you want to touch on the other models. Okay. So this was very, very nice and funny to do, and very tedious too. So now I will jump to the CNC milling machine. So the one we use is a Open Hardware 2, is a Shapeoko. You can build it yourself. The plans are downloadable. So it was very small at the beginning, something like 25 centimeter square working area. It was very weak, to be frank. It's not rigid. You can mill only soft materials. So okay, you see this is a door frame, and you see the size of the milling machine. Then after some time it was too small for me, so I made it bigger. I added second motor and things like that to have 80 centimeters working area, so that I can do bigger work, but the bigger, the less rigid. So I lost in rigidity what my improvement brought. So it's still quite. It's for that I don't have anything to show you here because. So I use it a lot for 2D works, so I don't use Blender for that. So I recycle compact discs a lot. If you want, you give it to me, because nobody uses it anymore, and you can do very nice things with it. It's very difficult to work with CD, because if it's too fast, it's too hot and it's melt down, and if it's too slow, it breaks, so it's not an easy material to work with. Again, this is just, I wanted it to go back. Okay, this is the Chantier Libre, is the name of our makerspace with its logo. So to mill in 3D, this was my first 3D test, but as it's in foam, in a polystyrene, after 2 conferences, it's just totally crashed in. So at the beginning, when I used it, the workflow was quite tedious, because you had to use Blender, export it in STL, open it in PyCam, which is a Python program, software. Some version of Blender were not working with the same version of PyCam that was working with the version of J-code sender to send it to the machine, so you always jump back for, so never remember. And then there is one guy, I don't know his name because he didn't put it on his website, so, but I thank him a lot. He made a version of Blender which is called BlenderCAM, which allows you to define the path for the tools directly in Blender. So I will make you a small demonstration. For demonstration, I use a file I showed last year in my conference. It was for an architectural competition that I lost, but at least I used it again and again for conferences. It's in Amsterdam, it's for that I show you this example. So I designed the pedestrian bridge, and now my aim is to model it back in real life. So I will show you how I started to model the surrounding. And this BlenderCAM is really fantastic. The guy who did that, send him money a lot, because he did a wonderful job. It's almost no bugs, and it does everything you need. And when it has bugs, it even makes nice things like that. So how does it work? It's a special version of Blender, which is called BlenderCAM. So you download BlenderCAM. You cannot render anymore because the render settings are replaced by the machining settings. So here is the 3D file, the model in Blender. I just added the edges to make it more visible. I keep it, so I hide it so that we have more space. And here you have the settings to define the tool path, because a 3D milling machine has to cut in the material, and you have to say where it cuts, how. And you have a lot of settings. You can define several works, several passes, because generally you do one pass with a big tool to go fast, and then you do the finishes with a smaller tool and with a slower feed rate. So you can define several passes. Each one can have his own tool here, and you have some presets of cutters. with the size, the diameter in millimeter, the end, because some of them are round-shaped, some of them are flat, some of them are V-shaped. So everything is here. You have the speed, you have the type of work. So I just use the result, and then you have one big button here, calculate path. And the result is something like that. So it's a mesh, basically, made with vertices, and that shows the path of the tool. And at the same time, when you click calculate path, it's quite long. So on my laptop, I calculated it again already. It will write in your folder, in your computer, a G-code file that you can send to the CNC milling machine, and it will keep inside Blender the mesh that shows you the tool path. What is nice is that it even can simulate the milling. So here it's a roof path with 8 millimeters. I forgot the name. Beads, drill. So here's the model, and here's after simulation how it will look like with the 8 millimeter drill. I cannot rotate. I don't know why. Oh. And you see that it can show you if you have enough precision or not. Okay, generally you know that with 8 millimeter drill it won't be enough. And then you generate the second, I will put full screen because this is the finishing path. So here I asked it, you have a lot of options. This one is in 2 ways, so it will mill first vertically in y-axis, and then a second pass in the x-axis, so that you have a nice finishing. And you have another example of another option is what is called the waterline. In this one, it will turn around the mesh, so that you won't have, for example, when you have a cube. The drill is a cylinder, so every time it stops in the face of the cube, you have those small cylinder parts. It's okay. So, and what is funny, this one is just for fun, is that as it's a mesh, you can convert it to curve. And you can use it to make some artistic work, or you can animate a camera along the curve. So this is the camera on my drill, and you can see exactly what it will do. And sometimes it makes very beautiful curves, so it can be, okay, I'm sure some artists may have ideas of what they can do with all of those curves. So here's a video of this is the rough part with the 8 millimeter drill. So this is foam, insulation foam, because it's very easy, so I can do it fast. In wood, it would take me at least 20 hours of milling, and I'm sure my CNC milling machine will break down before the end of the work. So for safety reasons, and to be sure to have something to show you, I did it in some foam. So basically, it follows the milling path in the 3 axes. So you can define the speed. My own, I cannot adjust the speed of the spindle by the software, but in the BlenderCAM, you can specify for each tool the rotational speed, the feed rate, the security distance, and this is the finishing path. So it has already did it in the y-axis, and now it's doing it in the x-axis to remove. I don't know if you see, maybe you see it here. You see those small stairs here. It's the tool that comes, and it's making stairs. So you go in the other axis to remove the things. So it was too big to bring it to you, so sorry. So what's next? I would like to take my pedestrian bridge that is made of slices like that, and laser cut it. So I have to try to write or find somebody to write me a Python script to project it on a flat plane and then laser cut it. I know that there was one French guy working on a laser cutting script, so that when you have a mesh, you can specify how many slices you want, and so that it cut it. I think he never finished the add-on. It's a pity, but I think there should be something to do here, so that from a 3D mesh you can have some slices, and then you cut it and you put it back, and you have your mesh in 3D. And then what I want to do with this thing, I will show you if I have 1 more minute. Okay, this is my sorry, no, it's on the other Blender. The aim is to okay, I will not show it to you. It doesn't want. I think it's this one. Once you have those, this one is another project, so it's around where I live. I took the geographical data from the NASA site, converted it to mesh, then you generate the toolpath. So here's the toolpath to mill it. So it was the buggy picture I showed you. So it's for that I don't have it. But then what is nice is that inside Blender you can define the type of texture you want on it. So for example, this is the map, this is the aerial view, and this is the hills and tops and things like that. And then you can project this with a video projector on your mesh, on your solid that you have drilled, and you can even use a Blender game engine to add some interactivity. So I will have to steal one of those Kinect things that they have upstairs, so that you can, if people move around, then they can change what is projected in the game engine in real time on the thing. So maybe next year I will have finished this one and show it to you. But this is the aim: is instead of sticking with white foam, you project on it things that you can interactively change with Blender game engine. The whole process is in Blender, and I think I have to stop before. Thank you very much. Time for question?
Yeah,
okay.
It's time for a couple of questions, and in the meantime the light starts.
Okay. So if you have any question.
Just quickly, the BlenderCAM you said generates G-code files.
Yes.
And I happen to know that a lot of 3D printers use G-code as well. So have you been able to use BlenderCAM to generate something for your Ultimaker?
I had the idea, and then I said I will first try to finish a milling work before. But it should be possible to print things with it. I think you can achieve nice results because it's making curves on the. But I didn't try yet. But as it's G code and it's written it's a clean G code, so I think there should be no problem to send it to the Ultimaker. I didn't try yet. I didn't want to break it too.
Okay, so. Thank you. Anyone? I think not. Thank you very much.
Thank you.
I don't know. I would like to have the wide screen. Either one does that, or only the HDMI? I think this one can do wide. Can this one do the HD? I think so. Ah, we'll see. Oh, my bad. Thank you.
So are you planning
No.
that's messing with So I'm looking for ways to mess around.